So why does the moon only have one side facing it? How is it possible that the moon always has the same side pointed towards us? Well, the simplest answer is, it turns one rotation around every month. Why is that important? Well, because it also goes around us once every month. So its day of the moon is as long as its year, if you want to count a year going around the Earth, right? So it turns around once every 28 days. It goes around this way once every 28 days. So that same side, as it moves here, it also turns enough just so that starts pointing towards us. Now, why would that be? The answer is because the moon, or the likely answer is, not the proven answer, but the likely answer is, the moon, we said, is mostly made of light material. In fact, this material looks suspiciously a lot like the Earth's crust. There is a heavy core. It's small, but it's not in the center. Now, we believe the reason why our Earth is symmetric and why our Earth is whatever, because at one point we were molten. We were big old molten metal blob. And the heavy stuff, since this is all liquid, the heavy stuff sunk to the middle, following gravity. So the heavy stuff, and then the less heavy stuff, and the less heavy stuff, and then the lightest fluff on the top we call continents, and we live on them. Okay? And so we believe that the reason why everything's floated towards the center is because the Earth was all really, really hot. Really, everything was metal. Sorry, everything was molten. Everything was lava. That lava, the heaviest stuff, sinks to the bottom, and that makes perfect sense. The moon shows a similar problem. It looks like at one point it was one big pile of goo, one big pile of hot, molten magma goo. So it should have done the same thing. The core should be in the center, but the core is not. Something pulled the core out of the center. What could it have been? Earth. While this thing was turning into a solid rock, cooling off, the core was pulled down towards the middle, but it was also pulled this way by the Earth. And that pulling that way by the Earth caused it to be a little off center. Because of that, as the moon goes around, the Earth is pulling at this mass that is just, if it gets a little bit to the left or right, it pulls it more back towards it, right? And so the facing of the moon, if let's say something perturbed it and caused it to want to move a little bit out of the way, what would happen is it would move this thing away from, here's the heavy part. So let's say the heavy part's now over here. Here's the middle of the moon, and here's the Earth. Well, the Earth's going to pull on this, right? Which is going to cause the moon to swing back this way. And so what's happened is, because the Earth, while this thing was cooling off, allowed the core to sink down towards us a little bit, that sinking down has locked the front of the moon towards us the whole entire time. And so therefore, that's why that's happened. It also suggests some very spooky things. When we went back and looked at the moon carefully, we sent some astronauts, and they found that the surface rock, the oldest surface rock they could find, was 4.001 billion years, 4.011 billion years old. Again, that's done through carbon dating. It's going through radioactive dating. What they discovered is the rock it was in, because of the crystal that formed around it, had to have been about 4.3 billion years old. Now, what that means is that we think the oldest rock that an astronaut walking around the surface of the moon picked up was 4.3 billion years. You can't find anything like that on Earth. Why? We have an atmosphere, we have rain, we have sun, we have wind. Our rocks get broken into little tiny rocks and turn into other rocks. It's a pain in the neck. We also, by the way, have something called plate tectonics, which is constantly recycling our surface material. So the bottom line is we just don't have rocks like this. We have some old ones, but nothing like this, 4.1001 million years ago. We have found crystals inside of rocks that approach 4 billion years old, but they're not. They're short of that. Looking at where we picked up this rock and looking at the surface of the planet and realizing that this rock had to have formed from a vast magma thing. Remember those seas you saw in the front? Those are big piles of basalt. Why is basalt important? Basalt is like volcanic rock. Those are the places where the moon cooled down. So let me get back to there if I can. See this? I gotta save it. Hold on. They're not gonna let me draw it. Oh yeah, do let me draw it. That's interesting. That's gonna be a problem later. All right, whatever. I'm gonna draw it. See this? That's a pool. You know, Galileo wasn't that wrong. He was actually pretty close to right. Why? Because that's where the pool cooled down. This pool of magma, not water. This is magma. It's basalt. The same basalt we find on the planet Earth when it comes out of volcanoes. So the whole surface is one big volcanic mess. Again, proof before we talked about before is that there was a surface, at one point the surface of the moon was all one big magma goo. These came later and these are craters. So when we look at the rocks, we realize, okay, they're 4.3 billion years old, but they cooled after 4. What cooled them off? Time. So we come to the conclusion that they're about 4.4 to 4.6 billion years old. Why is that important? Well, there's one other thing you need to know about the moon. The moon is leaving us. I know it's rude. 1.5 inches a year. Now, why is that important? Do a little math. Where was the moon, assuming that nothing's speeding up or slowing it down beyond normal gravitational forces, where was the moon 4.5 billion years ago? Yeah, it was right here. And so the belief has come to our belief that what we actually are looking at is the moon. Something came along, struck the surface of the Earth, scraped up a great big pile of goo from the surface of the Earth, extracted a whole bunch of stuff, and blew it off the surface. Actually, I can draw this better than that picture. Hold on. New. So here's the Earth, which would have been still primordial, still would have been pretty molten. Along comes a rock, strikes the surface of the moon, of the Earth, boom, this whole thing blows off into space. It becomes a very big pile of its own goo, which slowly coalesces because of gravity into a molten moon, which is orbiting us. Which means the surface of the moon, the moon is made of surface material from the Earth, and we have great evidence for that. They're virtually the same composition. And so the answer to all questions about the moon is it formed 4.5 billion to 4.6 billion years to 4.4 billion years ago. That's when the Earth formed, by the way. That's when our molten situation happened. The moon cooled down. Because its core sunk down towards the Earth, the moon got fixed, pointed towards one side being pointed away from us. That fixing caused the backside to get pummeled by what had to have been a whole bunch of rocks 4.3, 4.2 billion years ago to 3.5 billion years ago. Some of our craters, we think we aged them out about 3.5 billion years. And so this is why the moon is the way it is, and this tells us a lot about the Earth, how old the Earth is, how the Earth was made, and why the moon is the way it is. Okay. Also, some reminders: the moon has no atmosphere, which is why it has massive numbers of craters on it, and why one side is hot and one side is cold. This ends Moon Part 2.